Hello, welcome to the quick review session of Module 15. So what we looked at in Module 15 and what was our need and motivation was that we have a lot of changes happening to systems. Changes could be updates, defect fixes, as well as roadmap changes. We build platforms, we take products and port them onto newer platforms, or there is change in technology over a period of time. This change makes it crucial for products to still work in the newer environment with newer changes, newer fixes. And we need to ensure that the base always works. Newer features also work. So overall product quality is maintained. We need high quality products. Pictorially, if you see, new products from version to version, they become a minefield of bugs. And especially if they are large products with millions of lines of code, it is really important to maintain a lot of things from a data perspective, from a perspective of even code. The past test cases, past rounds, past data becomes very useful in such situations. And as you can see, there'll be newly added stuff, modified stuff, deleted stuff, as well as the unchanged base, which need to remain unchanged from a perspective that we have not made it buggy by all those changes that we have made on top of it. In addition to this, we also would like to make sure that with increasing and the number of changes, we want that our test cases are also optimized, minimized, and prioritized. If test case keep on increasing, the effort required also will keep on increasing. And for little things, for a little feature on a big base, our effort required for testing will be huge, which we do not want. So we got to employ techniques which will allow us for a little or a small feature, we probably have a little more than the feature's effort. Thus the motivations here are, well, we want to make sure that we have optimal use of resources, do more with less, best use of resources, and also want to make sure that we have a very, very efficient team. So minimization. For minimization, again, this all is based on a criteria C, as you can call it. So we look for requirements coverage, look for code coverage, but there needs to be a criteria. And we have looked at various criteria through earlier modules. But all of test case minimization optimization will require a strong and a solid criteria. It could be related to code coverage, requirements coverage, design coverage, or data and control flow. Most of the times at a high level, you will find that these are the three areas which will definitely be part of the criteria. One other way of minimizing is to discard redundant test cases, keep on discarding them. One way to look at it is optimize. If there is redundancy, optimize. Automate. If you automate the test cases, the time required will be very less because there is no human intervention over there. But again, you do not want redundant test cases. So reduce that set. The next thing would be to prioritize. Prioritize again based on a criteria. So you'll always have this criteria which would be required. Requirements coverage, code coverage, design requirements, some metric, architecture validation, or in fact customer requirements, acceptance testing. A lot of pieces can go into prioritization, but there has to be a criteria C. Optimization. We want best of the breed. If I have got 5 or 6 test cases, I would want to make sure that I've optimized the number in a manner that I always get best of the breed. And then I look at certain techniques like orthogonal array, combinatorial, in fact, certain choices of values in EC. When I've got a full domain divided into certain subdomains, which value do I choose if dot represents a value also becomes crucial. It may be domain driven. Special value, the number pi, which is equal to 3.14 something, depending on what kind of calculation we are looking at. And two other pieces that come into play is the execution trace and the dynamic slicing. Again, key areas for selection of regression test cases would be based on execution trace. We added some piece of code or we deleted some piece of code, and that made a shuffling in the nodes that are going to be followed when a particular execution is going to happen, which means there is a change. And if you recollect, we could do the paths from point A to point B, and path testing will uncover a lot of issues, and that's what execution trace can do for us. Well, execution trace is based on control flow. We also are looking at affected variable pieces, which we looked at during define and use. That could be taken in as a part of execution. Thus, from point A to point B, if I've made changes and affected variables are being looked at, knowing that they are getting affected in the manner that they should be because of the change will ensure that we do not have buggy code. We have high quality code. That's the dynamic slicing. Both these definitely require execution. However, in the background, modeling, understanding, static analysis can also help derive some of the test cases. So in the overall test case, minimization, optimization, prioritization, I think we looked at it from those three perspectives. However, I think it is all a regression view as well taken in. So we're looking at regression needs these, whereas these three are also standing on its own. At any given point in time, we would want optimized, minimized, and best test cases for us, which we could prioritize in a certain manner with a criteria. That will lead to selection of a test suite which is most appropriate and always provides results which help us build a high quality product. Thank you.